1/3 of everything shipped across the world's oceans is crude oil. That single statistic defines the scale of what we are here to discuss. Every barrel that moves from reservoir to refinery represents a complex chain of engineering, maritime logistics, and strategic infrastructure. And because this system operates largely beyond public view, miles offshore, across open ocean, through pipelines buried beneath the seabed, its complexity is often underestimated. Today, I will walk you through the 3 critical phases of this supply chain: extraction, maritime transport, and downstream distribution. My objective is to provide a clear operational overview of how crude oil moves from the subsurface to the end user, and to highlight the strategic constraints that govern this global network. Let us begin at the source. The journey starts not on land, but in water depths that push the limits of industrial capability. In ultra-deepwater basins, extraction occurs at vertical depths exceeding 12,000 feet. To put that in perspective, if you stacked 4 of the world's tallest skyscrapers end to end, they would still not reach from the seabed to the surface. Operating in this environment requires a fleet of highly specialized assets. The choice of rig type is dictated entirely by water depth and project duration. For shallow water developments, jack-up rigs are deployed. These units rest on legs that extend to the seabed, providing a stable platform for drilling and production. For deepwater operations lasting years, semi-submersible platforms are the standard. They are anchored in place and designed to withstand the roughest sea conditions. And for frontier exploration in the deepest basins, we use drill ships. These vessels carry the drill through a moon pool in the center of the hull, and they maintain position using dynamic positioning systems rather than anchors. Each of these assets functions as a self-contained industrial facility, housing crews, processing equipment, and safety systems, operating thousands of miles from the nearest coastline. Once crude is brought to the surface, the next challenge is moving it to shore. The first leg of this journey is often invisible. A vast network of subsea pipelines transports crude directly from offshore platforms to coastal terminals. This is the most efficient and quietest segment of the supply chain, but it is only the beginning. For intercontinental movement, we shift to maritime vessels. Here, the scale becomes staggering. In 2021, the global oil tanker fleet had a combined cargo capacity of 619 million deadweight tons. To give you a sense of magnitude, that is enough to carry the equivalent weight of approximately 1,700 Empire State Buildings in a single voyage cycle. But not all tankers are the same. The fleet is divided into 2 distinct categories. First, we have crude tankers, the VLCCs and ULCCs, or very large and ultra-large crude carriers. These are the giants of the industry. They transport unrefined feedstock from export terminals to refineries. Their size, however, imposes strict routing constraints. Many are too large to transit the Suez or Panama canals, forcing them to take the long route around continental landmasses. Second, we have product tankers. These vessels carry refined products, gasoline, diesel, jet fuel, from refineries to consumption markets. They are smaller, more flexible, and often equipped with epoxy-coated tanks to handle multiple fuel grades without cross-contamination. Where do these vessels go? Despite the vastness of the oceans, global crude flows are concentrated along 4 primary arteries. These routes are not arbitrary. They are dictated by geography, vessel size, and the location of the world's major producers and consumers. Route 1, Persian Gulf to Western Europe and North America. This is the primary corridor for VLCCs. Because these vessels cannot transit the Suez Canal, they must navigate the Cape of Good Hope, a voyage that adds significant time and fuel consumption. Route 2, Persian Gulf to Japan. This is Japan's energy lifeline. Here, vessel size determines the path. The largest tankers use the deeper Lombok and Makassar Straits, while smaller vessels take the shortcut through the Strait of Malacca, one of the world's most congested maritime choke points. Route 3, Persian Gulf to Europe via the Suez Canal. This route allows Suezmax-class tankers to bypass the African continent entirely, saving thousands of nautical miles. It is a critical artery for European energy security. Route 4, Mexico to Japan across the Pacific. This route illustrates the strategic constraint of the Panama Canal. Only vessels that fit the Neo-Panamax locks can use the canal, all others must make the long Trans-Pacific crossing. These choke points, Malacca, Suez, Panama, the Cape of Good Hope, represent points of vulnerability. Disruption at any one of them has immediate ripple effects across global energy markets. After thousands of miles of transit, the crude arrives at its next critical node, the refinery. Here, the raw feedstock undergoes a transformation. Through distillation and chemical processing, it is separated into the products that power industrial economies: gasoline, diesel, aviation fuel, and petrochemical feedstocks. This stage is where the potential energy extracted from deep beneath the seabed is finally unlocked into usable form. From the refinery, the supply chain enters its final phase. Product tankers and coastal barges distribute refined fuels to regional storage terminals, and from there to retail and industrial endpoints. This last mile is characterized by high frequency and low margin, a sharp contrast to the high capacity, long-haul crude transport that precedes it.